Well, howdy YouTube, Unky Joe here, Unky Joe's Playhouse. Today, oh lordy, have we got a video that has taken a while to make. And I'm about to tell you why. Alright, so we're all guilty of it. I went down a YouTube rabbit hole one night looking for old server motherboards and Xeon processor combinations. My intention was with this board, and you see I'm running Ada here, I'm burning it in. This is a Supermicro 8X SIL. Now, initially I looked at the SIL-F board, and in my zest to buy this thing, I bought the 8X, or X, yeah, 8X SIL, not the minus F. So that meant I didn't get the built-in IPMI or KVM or like iDRAC or the IBM remote software. I got it because it had an 8X PCI Express slot that had a slot cut out the back of it, as you can see on this video. So what I'm doing here is I'm burning it in on the bench. I've got an X3470 Xeon processor in there. And also another interesting fact is when I bought the RAM, I got the wrong RAM. I initially bought 32 gig of RAM for this. It was going to be an Unraid server. RAM didn't work, so I contacted the seller of the board and asked him if he had any ECC RAM that he knew would work with this board, because Supermicro is super picky on RAM. And he said he did, and he gave me a really good price on it for 16 gig of RAM and sent that to me. And then I could take that other RAM and put it into one of the Dells or the IBM. And I just set it up with a 2.5 inch notebook drive I had laying around, and I'm running Windows Server 2019 on it and burning it in with Ada. And this is all outside of the case. Now, this case you probably remember from our video about pfSense. This was our pfSense firewall until we got the Dell R210 Model 2. And it's just a standard $20 or $30 Rosewell case. Got a couple of fans in it. It's got a lot of drive bays, but I took a lot of those drive bays out. Now, what I didn't do when I got this case was save those little inserts for the standoffs for the motherboard, because they're very specialized and very hard to find. And as it was, I only had 4 standoffs installed in this motherboard, or in this case, but I did make it work. Now, the seller of the board also had the backplane for the device and sent that along with the motherboard as well, so I had everything I needed. And then to put everything together, so like I said, it was just running the burn-in test here on the board, or on the system bench. It has 4 serial ATA ports. It's got an onboard USB. It doesn't have USB 3, no IPMI, but it does have dual NICs, and it would initially, like I said, it was to build another Unraid server, but you're going to see I end up using this for Windows Server 2019, and I get into the reasons why here shortly. So, and you can see on the bench it's running about 60 degrees C on the CPU, so not too bad. That processor is a 95 watt TDP processor, so it can pull a lot of current. But here it was just running Ada and a stress test outside of a case. Now, one of the things I didn't like was the power supply I had in this unit. This is one I inherited actually from my stepfather. It's a 750 watt power supply, but it's got all these power leads, and they're thick, and I mean, it's a well-built power supply, but it's really overkill for what I needed. So I went ahead and I purchased a 500 watt power supply to put into the unit, and that is the this one right here. It's a Thermaltake 500 watt smart power supply that should be it's ultra quiet, whatever that means, but it's an 80 plus certified power supply, so it's better than the one that's in there. It'll use less energy, and that's the whole goal of this bill, is to make it as frickin' frugal as possible. So this is the power supply I ended up going with it. And the other thing is it has fewer leads on it as well. Alright, so I'm running Ada 64 on this, and the CPUs are, this is with the cover off on the unit, and only a CPU cooler. None of the fans in the front of the unit are running in this 2U case. And my CPUs are getting around 70 degrees C with the cover off, only using the CPU cooler, no front fans working. And in Imperial, that's getting up to about 158 Fahrenheit, 162 on one of the cores. And I think I can change this to Celsius. Yes, I can. So right now they're running at about 64, between 60, well, it fluctuates, between 65 and 70 C for those of you that are doing the metric scale. Now I'm going to go ahead and stop Ada, and then I'm going to put the cover on it. I'm not going to screw it down or anything, and then I'm going to run Ada again and see how different our temperatures are. So I'm going to go ahead and stop Ada from running now, and we'll see how the temperatures come down. I'm going to give it about 5 minutes to stabilize and cool down, and then we'll come back and look at the temperature readings. Alright, so we've let the unit sit now for about 5 minutes, and our temperature has come down to about 33 C, or about 90 degrees Fahrenheit, 80 to 90 degrees Fahrenheit, depending on what you're looking at. So what I'm going to do now is physically get up off my bohunkus, and I'm going to go over to that PC, and I'm going to put the lid back on it, and we're going to see what kind of change we have. So I'm going to mute the microphone here while I do that. Okay, so the front cover's on. We're just going to let it monitor here for a few minutes and see if our temperature goes up any. Okay, so our temperature's risen a bit. We're now running in the upper to or middle to high 80s, upper 90s, just putting the cover on. Now, the problem I was having before was that under load this server started to beep because I have, I think it's 170 degree set for my temperature for the alarm to go off. This is it's a server motherboard without an IPMI or an iDRAC controller, you know. But that's okay. I got remote desktop, so I can get into it. But anyway, I digress. So the temperature's gone up 1 degree. So now what I'm going to do is I'm going to go ahead and start Ada again. And I'm going to switch back over to centigrade. And you'll see our highest temperature before was 165. So I'll tell you what I will do. I'll leave it at Fahrenheit for now, and then I'll switch over to centigrade once it gets up to temperature. So I'm going to go ahead and click on Start. And you can see, even with the cover off, we got pretty close to that 170 degree mark last time. So it's now 10:50. I'm going to let this run. And if my alarm goes off, I'll come back and let you know. Wow, what a difference a few minutes can make in a cover on a PC. Look at those temperatures. Way up there. I don't like any PC running or any computer running at those temperatures. Let's put it in Celsius because it's up about almost 90. Yeah, it is around 90. It peaked out at 96, and you hear it? Overheating detected. So now it's going to throttle the CPU. And the speed should start dropping down here on the CPU. And it does. So I'm going to go ahead and stop Ada at this point. We're going to need to figure out a solution for this unit because I am not going to be able to run it under load with that cover on. In fact, I'll just walk over there now and take the cover off just for giggles and see what the temperature comes down to. Alright, so there's the cover off, and immediately you can see the temperatures coming back down to a more reasonable level. I'm going to leave Ada running, and we did hit the magic 90. I think I set the temperature at 90 for the alarm to go off at 90 C. I think that's what I set it to, but as you can see, the temperatures are coming way down. So, yeah, doesn't mean I can't use the machine. It just means I can't use it right now with the cover on. So I'm going to order some Noctua fans, and they should be in within a couple of days, and we're going to pop them in there and see what kind of difference in temperature we get. Because, frankly, the only fan I have in that unit is the power supply fan, and it does not do a good job of exhausting heat. And then I have the CPU cooler, and even though the air is being moved down over the CPU cooler, there's no way to exit it out of the machine because the fans I have on the front are not working. So we're going to get them working, and then try some Noctua fans and see what a difference it makes. Alright, so let's go over what's in the rack. This unit right here is the Dell R210 Model 2. That is my pfSense firewall. This 4U unit underneath it is my Exponology NAS. That is running my home audio, video, Plex, MB, you name it, it's running on here. And the beauty is it's running the Synology NAS software, so I can run any other number of applications on there. And then of course I have my handy dandy trusty Synology NAS, which is still running well. And then down below here, I have those 2 Dells and that 1 IBM. The top Dell is my archive server and my backup Hyper-V server. So if I need to move anything around as far as my virtual machines on my network, that's what that unit is for. The unit underneath it is the other Dell R710 that was donated. And that one has 2.5-inch hard drives in it. And right now it's a Windows server, Hyper-V server, and it's where I'm running all my virtual machines on. And then the unit below it is the IBM 3650 Model 3. So here's the deal. I need to save power. I'm spending way too much money on electricity to run this rack. I mean, it isn't an issue, but I'm just, if I don't need to run these large Dell servers and the IBM 24/7, then why should I? That Dell, when it's running with the VMs on, pulls about 250 to 260 watts. If I can create another server to run my virtual machines on that I run my business on, that only pulls 50 or 60 watts, I'd be saving a hell of a lot of electricity every month, considering that server is on 24 hours a day, 7 days a week. So here is the plan. The top Dell server is going to keep running Windows Server 2019. This Dell underneath it, everything is being moved up to that Dell on the top. And then what I'm going to do is move, eventually, those virtual machines off to a low power usage machine that I have on the bench right now. And then what I'm going to do is set up a cluster between the middle Dell server and the bottom IBM that are going to run XCP-NG. And then this one will still, the top one will still remain running Server 2019 and Hyper-V and Drive Bender and all that good stuff. And then I only need to turn these servers on when I'm doing labs. So they won't need to run 24 hours a day, 7 days a week and eat up a lot of electricity. So this unit, what I'm going to do is take the SSD out of that Dell. And that's a 1 terabyte that was donated by Sasha. I'm going to install that 1 terabyte SSD into here, install Windows Server 2019 on it, and then move my virtual machines that run 24 hours a day, 7 days a week, namely my Active Directory domain controller, my surveillance software, my phone system. I'm going to put them on this little unit, which draws about 50, 60 watts at idle. I would imagine 80, 90, 100 watts under load, so that it can handle and use a lot less electricity. And then when I'm doing my labs or I'm working around and making YouTube videos, I can fire up the Dell or the IBM as I need them. Now what I need to do, I've got this machine shut down. I need to go ahead and pop this SSD drive out. There we go, there's our SanDisk. Ultra 2, a little dusty. That server, as you can see, is going to need a good clean out. And I'm going to have to find a blank to put in there. But let's take this over to the bench, because what we're going to do is we're going to transfer this SSD drive into this server that I'm building. And so we'll need to take this SSD drive out, mount it in here, and then mount it into the server, or the replacement server, and then go ahead and start our Windows Server 2019 install on this. We'll have to get Blue Iris reinstalled on here, and then we'll have to put the Hyper-V machines on there. So it's going to be a long, involved process, and I'm not going to show you the installation of Server 2019. You've seen that before, but I will come back and show you when I move the virtual machines off of the temporary Dell I have them on now. Now, come to think of it, I had a Seagate 1 terabyte mobile hard drive laying around. So what we'll do is, instead of putting a blank back in that Dell server, I'm going to go ahead and install this in there. This server is going to be running XCPNG. In another video we'll get to that. But for now, we'll just go ahead and pop this into that server. And then we'll have it available for XCP when we go to install that. Okay, so let's come back to the bench and let's get that SSD drive installed. I've got it removed now. This is the one that Sasha Lopez donated, and we're going to put it to good use in this server. And so there you go. Alright, so when I removed Zeus, which was that Dell R710 when I deprecated it, I moved all the virtual machines I had running on it, which consist of Windows 10 virtual machine, that's MCS 002, my domain controller, and then my PBX system. So these two machines can be moved while they're running, but the PBX cannot, because it's a Linux-based PBX, and it's not advised to move them while they're running. So, but I'm going to show you how easy it is to move it over to the other server now that we have Zeus up and running. So I just simply right-click on it and I choose Move. A little wizard pops up. I click Next. I'm going to move the entire virtual machine, so I'm going to click Next, and I'm going to move it to Zeus. Click on Next. Zeus is not configured to send or receive live migrations of virtual machines. To fix this, modify the Hyper-V settings on the destination. So let's go over to Zeus. So let's bring up Zeus, and Zeus right now is running the Blue Iris software, so that's why you're seeing the processor stuff going on. And I thought I had configured this when I installed it, but I guess I didn't. So let's go to Hyper-V settings, and let's go to live migrations and enable incoming and outgoing live migrations. Click apply. Let's see. Oh, I need to add a network. Use any available network. Click on apply. Click OK. Now let's go back to Prometheus and let's try this again. Okay, move the virtual machine's data to a single location, and I've already got a virtual hard drive storage set up under Hyper-V on the D drive, which is an SSD drive. Click Next, click Finish. It's probably going to prompt me for a network adapter. Nope, it's going ahead and moving it. So we'll let this run. We'll come back when something changes. Alright, so we've successfully moved the phone server. So let's go over to that. Let's go over to Zeus here, and we should see the PBX system is on here now. So I'm going to go ahead and see if this will launch. Click the start up. And yes, Linux machines run very well in Hyper-V. I've never had any trouble getting a Linux machine to run in Hyper-V. FreeBSD, that's a different story. But, and Sangoma has written their own version of Linux, I guess. I think it's CentOS is what it's based on. But that's neither here nor there. We want to make sure now for all intents and purposes, our PBX should be up and running. So we'll leave that running. Let's see what kind of impact that had on our system. Our CPU usage has come up a bit. Our temperatures are still good on that machine. Remember, we were having some trouble with that unit overheating. Let's get this virtual machine. Let's go ahead and move it as well. And we're going to do Zeus. We're going to move everything to a single location. Gonna put that under the VHD store, which is an SSD drive that we just installed in there. Click on finish. Let's see if it works. Good. And I've kept the network adapter's name the same, so it's not prompting me to give it a new network adapter name. Alright, so that move of that virtual machine took about 10 minutes. Now, scary, right? This is why I love Hyper-V. Now, I'm not familiar enough with ESXi. I'm sure you can do this on ESXi. You can do it on XCP, NG. I believe you can do it on Proxmox as well if you've got it configured correctly. But this is why I keep running back to Microsoft. I'm going to move this virtual machine while it's running to another machine, and there should not be any interruption in service. So let's go ahead and right click on it. We're just going to tell it move. We're going to do the same thing we did for the other units. We're going to move them to Zeus. Click on next. Move the virtual machine data to a single location. It's about 70 gig in size. We're going to put it over on that SSD drive under the Hyper-V folder. Next, finish. And let's see if it prompts us for a networking card. No, probably not. So that last move took about 10 minutes. This one is going to take a bit longer because it is looky here. The hardware in the destination computer is not compatible with the hardware requirements. Okay, so, alright, so a couple of things. One, I did all the updates on the virtual machine. I did not have all of the current updates installed. Now, I think what's causing this problem is that the processor in my Dell is quite a bit different. I think it's a X5470 or a 5740 in this Dell, and it's being moved over. In fact, let's find out what processor this is in this Dell. Let's go to Task Manager. It should tell us in here. So this is a, I'm sorry, it's an E5640 CPU, and I'm moving it over here to Zeus, which is a X3470 Linfield processor. And I think because this processor is not supported for the Spectre mitigation, and the other Intel Xeon processors are, I think that was what my problem was. So I ran across an article that told me to put the processors on the virtual machine into what's called Compatibility Mode. Let me see if I can show that to you on Zeus real quick here. So if I were to go over to, let's go to MCS2, right click, go to settings. If you go down to the processors and click on that, I did not have processor compatibility checked, and that specifically says migrate to a physical computer with a different processor version. So I didn't have to do that with these VMs, but I did have to do that with the Active Directory domain controller. And it appears that it is moving now. It is transferring the data. So we'll let this run. It's probably going to take 10 or 20 minutes to move this virtual machine, and it is still running, as you can see. So hopefully we'll have some success at the end of this. Ta-da! There we are. Okay, it successfully moved. So that's what I had to do, was to click the processor compatibility DLE on there. So one little problem. And it's not the CPU usage. Keep in mind I'm running Blue Iris on here, so Blue Iris takes a lot of CPU cycles. I'm doing good on memory. My Ethernet's working fine, but this is what bothers me, is this temperature on the CPUs. Now, my TGA max on this is 99C, and my minimum on here has been about 55 to 57C, and the max has gotten on 80 on one of those. This is a new CPU cooler. The problem is, this is an itty-bitty 2U case, and I'm using the stock fans that come on the front, and I just don't think it's moving enough air. I mean, this is not critical. It's not going to break or anything. It's not even getting to the point where it throttles the CPU usage, but I just like them to run a little bit cooler than that. So I've ordered a couple of 80 mil Noctua fans. They're gray ones. They're PWM fans, and I'm going to put those in there when they get here tomorrow, and then we'll see what kind of temperature readings I get. Now, you've probably already noticed this video is getting a little long in the tooth, and that's okay. Just so you know up front, this is a long video, but I had a lot of information to share with you. So, I got the Noctua fans in, and you can see them there. They're in the pretty box. Now, what I didn't tell you is that before I ordered the Noctua fans, the two fans that came with this case, I went ahead and wired them up. I jury-rigged. Polish engineered, as my father used to say, the fans to run, get their power off the motherboard. That way I could put the cover on and see what kind of cooling effect they had. And then now that the Noctua fans are in, I'm going to install them. And what I was doing here was actually shutting down the machine, getting it prepped to install the fans. Now, the other thing I didn't share with you, and I really didn't know, is how troublesome it was to get to these fans. You have to take off the side brackets. You have to take off about half a dozen screws, and that's what I'm doing here. So I've really spread this video up. You can see I've had to flip this thing over. I had to look at it closely to make sure I was removing the right screws. Also, the control panel on the front where the push buttons are and the USB ports is going to have to come off. All of this just in order to get to those fans, to the fan mounting bracket that is inside. And you'll see I missed a screw, but there's the cover. So I've really sped up the footage on this as fast as I can, and I'll just kind of narrate as we go along. So you can see my blue painter's tape on there insulating the connections. And you can see I had to take the front cover completely off just to get to these fans. And then, of course, the great unboxing of the Noctua fans. And I just got the basic PWM mode fans. I think they were $10 a piece on Amazon. And they went in there very easily. Of course, you have to pay attention. This thing sucks in air through the front and blows it out to the rear. And but the fans went in without any issue. Now, these fans are the basic $10 fans, so they don't come with any extension cables on them. They don't come with the thing to make the noise lower. I wanted these fans to run at full bore. They're 1800 RPM fans. That's also one of the reasons I ordered them, is they're a little higher airflow. And then I'm trying to figure out how this all goes back together. So I decided eventually the best thing to do was put the cover on first and then come back later and put the control panel on as an afterthought. So that's what I'm doing here for you to see. And I'll be honest with you, out of all the things I had to do, this is the thing that took the most amount of time. Now, one thing I haven't explained to you, and I don't remember if I display it moving on, these Noctua fans, as opposed to the fans that were in there already, really didn't make that much of a difference. Maybe a 2 to 3 Celsius degree drop in temperature. Not a huge drop, but hey, they're Noctua and they're quiet and they've got good warranties. Alright, so now the front cover is on. Now it's time to fix all the cables and pretty them up and wire tie them. And you know, the other thing that wire tying helps is to keep the cables out of the way of airflow. And then of course I powered the unit on, checked it for airflow, and I'm going into the BIOS now and I'm setting up the speed of the fans. I just let them run full bore and keep the unit cool. That's what I'm after. This is going to go on the rack, so I'm not really worried about the unit being quiet or loud or anything like that. Now you're going to notice one hitch in the get along. You see how that I have bent this top cover at some point in the past. That's why it won't shut completely. So there you go. You see what it's taken to build this server. And I've been doing this for a month, so I've taken bits and pieces of this video and that video and selectively editing them here and there. And you just saw me stick those two new Noctua fans in to help with the cooling. Now, the fans I had in there before were the stock fans. They weren't really loud, and keep in mind this unit's going to go into the rack, so I'm not going to hear them anyway. They're in their own room. But everybody's all about Noctua fans, so I was like, all right, well, I'm going to order a couple of decent $10 Noctua fans that are PWM, I believe, fans. They have the 4-pin headers, and we'll try that. And I put those fans in, and really, They're a little quieter, but they made absolutely no difference in the cooling. Now, ideally, this super micro motherboard is designed to have a super micro cooler, passive cooler heatsink on top of it. And then what you do is you just have a high velocity fan like the super micro cases do, and they blow a lot of air over the top of that passive CPU cooler. So this is the cooler I had initially put on there. Now this processor is a 95 watt TDP processor, so I went on Amazon and I found a Thermaltake fan on there, and it's rated for a 95 watt processor, and I put it on there, and you've seen the results we've gotten. Not good. This thing is still running too warm, and look at the surface area on that heat sink. I mean, it's got a lot of surface area. Now, part of the problem is the fan blows down onto the CPU, and then we depend on those Noctua fans, which are up here, get it out in front of my face, to push the air through the case. I don't have any fans on the back of the case. But this was the cooler I was using. You know, it comes with its own little mount, and this works for it works for 1156 and 1155, and there's a whole bunch of CPUs this will work on. So I got to thinking for a minute. I looked around in my parts box and I found that I had a couple of these laying around. Yep, I know what you're saying. Stock Intel coolers suck. Actually, they blow. But they don't suck, they blow down onto the processor. But I had a couple of these laying around. So I took the Thermaltake off and I put one of these on. Let's go look at the results I got. So here you go. I just want you to see the server fully loaded. And this is the old CPU cooler. This is the Thermaltake cooler. And you can see my maximum temperatures got up as high as 78°C. And once I replace that with the stock cooler, put the cover back on, my highest temperature was 70°C. So it's pretty damn close to a 10-degree difference in temperature. And you see they have not changed since I took that screenshot. These are the live readings right here. So yeah, I would say in this case, in this Roswell 2U case, and in my circumstance, the Intel stock cooler works better, and it's smaller. It's not... Here, let's put them side by side. Hang on a second. Let me do this. Do them side by side. You can see there's the stock Intel cooler next to the Zalman, or next to the Thermaltake. And yeah, the Intel stock cooler does a better job. Don't ask me why. Probably because it has a copper core, and this one is all aluminum. But as you know, if you've ever dealt with these Intels, they got a copper core on them, and they're actually heavier. So that probably has something to do with transferring more heat. But just we'll take a look one more time. You can see what the temperatures are running that, and that's even after adding an additional virtual machine to this server. Now, if I hadn't seen it with my own eyes, I wouldn't have believed it. Now, why wouldn't I have believed it? Because everybody says that these stock Intel coolers are crap. Okay, well, I tell you what, I've never had one of these crap coolers fail on me, though. Never. Never. If it's an Intel, I've never had a fan go bad on an Intel. Just my luck. Intel stock cooler. Never. Never, ever. There's a 10-degree temperature difference between the Thermaltake and the stock cooler. Proof is in the pudding, folks. So we're going to go with the stock Intel cooler. It's keeping it 10 degrees cooler than the Thermaltake was. I'm not even getting close to the temperatures I was before. As I showed you a minute ago, we were getting as high as 78°C. The highest I got with the stock cooler is 70°C. And I've added another virtual machine to that server as well, on top of the surveillance and the domain controller and the phone server. So this is a little processor that could. Now these processors are known to run a little bit warm, but keep in mind I'm cramming everything into a 2U case and without a lot of really good fan circulation. So this stock cooler in combination with the fans I put in the front the other night seem to be making all the difference, and I'm confident now I can put this unit back into the rack. Now the other thing I did, because this is all about power consumption, right? So we went from the old Zeus with all these VMs up and running and the surveillance software running. It was pulling about 265 watts, 24 hours a day, 7 days a week. The new server, it pulls between 90 and 95 watts, and it gets as low as 65 watts when I don't have the surveillance software running. So we're saving money. We're saving to the tune of about $20 a month in energy costs. Well, actually closer to $15 a month in energy costs, or about almost $175 in a year, US dollars. So that's a pretty significant savings. It paid for itself. The motherboard, I think I paid $30. The CPU was $25. The RAM was about $50. It's 56, 70, 80. So I've got, and the case I already had laying around. So I've got probably plus the fans. That's another $20. So maybe $200 into this rig. Maybe under $200. I was able to build a server that is capable of running Windows Server 2019. It's got a quad-core X3470 processor, and it has 8 threads, or logical processors. I put 16 gig of error-correcting RAM in there, and then I'm using the onboard network cards, etc. And it's running like a champ. It's running as well as my Dell R710. Now, that doesn't mean I'm not going to be using these Dells or these IBMs moving forward, but these are 11-year-old machines, and they're not as power efficient as the new machines are. And it doesn't make sense to run them 24 hours a day, 7 days a week for what I use them for. And I'm just consuming power with no reason, spending money I don't need to. So we've got it off onto a smaller server now, less power-consuming server. I don't need all those cores, and we'll still be using the Dells and the IBMs when we do projects on that are specific to those two devices. So it's not like they're going away. They're just not going to be running all the time, but they're not leaving the rack. So there you go, YouTube. We hope you found the video entertaining and informative as always. Please give us a big thumbs up down below. Subscribe if you're not already a subscriber. Click that notification icon and leave your comments down in the comments section. We love, love, love your comments. Anyway, donate if you're so inclined. We take PayPal and we take Patreon. And please, don't forget to come back and see us again. And don't forget that we will see you on the other side.